this lesson is on factoring by grouping. When we factor by grouping, it tends to be when we have four terms in a polynomial. So this step that I'm showing you right now is actually the second step of factoring by grouping, but I wanted to show this to you so you can understand what's going on. 6 has a factor of 3x plus y, and z has a factor of 3x plus y. So these two both have a factor of 3x plus y. So think about if this was 6u minus zu. I could factor this by taking a u out of both of them and writing it as u and then 6 minus z. So that's essentially what's happening here, is that I've replaced u with 3x plus y. And so what I've done then is I've said, well, I'm going to divide this by 3x plus y. I'm going to divide this by 3x plus y. And I'm going to take that 3x plus y out front, and what I'm left with is 6 minus z. So again, this is sort of the second step in what we're doing with factoring by grouping. So when we factor by grouping, it's important to follow the correct steps. So first we're going to make sure our polynomial is in standard form. Typically it is, but just make sure. Remember, standard form means highest degree to lowest degree. So typically that will be like a x to the third power, then an x to the second, x to the first, and then a constant. Then we're going to group the first two terms together and factor out the GCF of those two. And we're going to repeat that for the second set of two and hope that those two binomials match up like they did on our last example. So again, my last example, I had these two binomials, 3x plus y, that were the same. That's what we're hoping for. And then, of course, if that does happen, then we're going to factor out that binomial. So let's take a look. I'm going to start by making sure it's in standard form. Now, on this one, it already sort of is in standard form. It's kind of tough to figure out a standard form for questions like this. But I'm going to look at these two together plus these two together. Okay, so I'm including the plus in this second set. And I'm going to make a point of that because this is the most common mistake I see people make. When I factor a common term out of 6ab and 21a, it looks like I can take out a 3a on both of those terms. So I'm going to rewrite that first grouping as 3a, and then if I divide, I get 2b minus 7. So again, I've sort of split it right here, and I've grouped this into 3a and then 2b minus 7. This is still a plus. And now I'm going to do the same thing here, 4b and 14. I can take out a 2. So I'm going to divide this by 2 and divide this by 2, and I'm going to write that as 2. And then when I divide, I get 2b minus 14 divided by 2 is 7. Now what I notice is I have the same factor of 2b minus 7, and so that's my common term, that's my common factor. I'm going to take that out front. So remember that next step, if we have a common factor, we divide by it. And I can divide this by 2b minus 7 and be left with 3a. And I'm going to divide this by 2b minus 7 and left with 2. And then don't forget to put my common factor of 2b minus 7 out front. Let's try another. This one, I am going to change this into standard form, so really I'm just going to flip-flop these two. I'm going to write this as x cubed and then plus 3x squared and then minus 3x and minus 9. So that first step was to write it in standard form if it's not already there. Now I'm going to split it down the middle, and notice this time I'm dealing with that negative, okay? That will come into play in just a moment. So again, looking at the first two, looks like I can take an x squared out of both of those terms. So I'm going to write that as x squared and then x plus 3. I'm going to keep my minus here, and I'm going to take a 3 out of these. So essentially what I've done is I'm going to divide it by a negative 3, because see how this is a negative 3? So I'm taking a negative 3 out of both. So negative 3x divided by negative 3 gives me x. and negative 9 divided by negative 3 gives me positive 3 or plus 3. Again, I see that I have that common factor of x plus 3, so I'm going to put my x plus 3 out front, and then what's left over is what I get when I divide by x plus 3. And when I divide by x plus 3, I end up with x squared minus 3. So that is my factorization. Try these two on your own, then press play to see how you did. For my first one, it's already in standard form, so I'm going to split it right here. Again, notice that I have a minus. Okay, so I'm going to accentuate the minus. For my first two terms, I can take out an a squared. So I'm going to rewrite that as a squared and then a minus 4. For my second two terms, again, I'm taking out a minus 3. So if I take out a minus 3 here and a minus 3 here, that gives me a positive a, because a negative divided by a negative is a positive, and 12 divided by negative 3 is negative 4. So be very careful with the signs on that question. Again, I appear to have a common factor of a minus 4, so I'm going to divide this by a minus 4. I'm going to divide this by a minus 4. I'm going to put that a minus 4 out front because that's my common factor. And I'm left with a squared minus 3. And my last example appears to be a hot mess, but we're just going to take it step by step. Again, I'm splitting it right here. This is a plus in between, so that makes me feel a little better. It won't be as complicated. Looking at 24 and 18, I'm going to choose to take out a 6. And I'm also going to take out 2 p's and a q. 2 p's and a q. So remember, that goes out front, 6p squared q. And then whatever's left over when I divide. So this would give me a 4q, and this would give me minus 3. 4q minus 3. So again, I'm hoping that that happens over here. I'm looking at these terms. I appear to be able to take out a 15, a p and a q. 15pq. Remember that 15pq comes out front, but don't forget there's a plus sign. Oops. 60 divided by 15 is 4. And dividing the p's, they go away, and 2q and 1q reduces to 1q. 45 divided by 15 gives me a negative 3 because of that negative, and then the p's go away and the q's go away. Again, it looks like I've got a common factor of 4q minus 3 on both terms. 4q minus 3. When I reduce, again, keeping that 4q minus 3 out front, that leaves me with 6p squared q and plus 15pq. And typically, that's where we would be done. Looking back at the beginning, I see that I missed that all four terms actually had a common factor, and it became obvious to me in this step, because if you'll notice, 6 and 15 have a common term of 3. So now I'm going to take a 3 out of both of these, and also a p, and also a q. If I reduce this by 3pq, again, I'm going to put that 3pq out front. And it doesn't matter the order that I write this because multiplication is commutative, which means the order doesn't matter. So I'm going to take this 3pq, I'm going to smoosh it out front, and then I'm going to write whatever's left over, which looks like 2p plus 5. So again, I could have avoided this situation at the end if I would have started by taking a GCF out of everything at the beginning, because everything in the beginning was divisible by this 3pq.